Hello everyone and welcome to my video about the Moneyball theory. Today I'll take you through how it has transformed the football industry and how we sign and recruit players. I'll firstly talk you through how Brentford FC have used it in recruiting players, leading to their first promotion to the Premier League in over 50 years. Then I'll go into detail about how Forest Green Rovers have used it, who are further down the football pyramid. Then we will try and combine both methods and see if we can uncover the next gem, the next superstar ourselves to scout for the team. Let's get into it. Can we find the next Haaland or Mbappe? Let's find out. Now, let's get into how the Moneyball theory actually started. Well, the evolution of the Moneyball theory overall transformed the way clubs scouted and recruited players. The whole concept behind it was buying players for a cheap price who are undervalued in the market, who you can then develop and sell on for huge profits in the future, and this was revolutionary. Now, the American baseball team, the Oakland Athletics, were pioneering in this new Moneyball method. They used statistical models to analyse players who were undervalued in the market to get the team better results. This worked a treat as it led to them winning 20 games in a row in one season, breaking numerous records in the process. Now that is ridiculous. A key statistic that the Oakland Athletics use is on-base percentage. Now this measures how often a player reaches the base. As you can see from the diagram, it's the number of times on the base divided by the number of plate appearances. This was effective as it led to them recruiting top players such as Scott Hatterberg, what a player he was, and led to them competing with the top teams in the league such as the New York Yankees. The New York Yankees had a much higher payroll of $92.5 million. This was compared to the Oakland Athletics' $32.5 million in 2000 season. And this is a prime example of how the Oakland Athletics were able to get better value for money players for a cheaper price and still compete at the highest level. I'm going to talk about how it has been successfully adapted from baseball into football. Matthew Benham, current owner of Brentford FC, invested $10 million at former club FC Midtjylland in developing the Moneyball theory. Having taken over Brentford, he had more plans to invest more money into it here and transform the way the club scout and recruit players. He used a key performance metric to do this in expected threat, which I will go into in more detail later. As you can see, here are some examples of the signings they've made under Matthew Benham at Brentford FC. You can see them buying players for a much cheaper, undervalued fee and selling for a much higher price, generating huge profits in the process. For example, Neil Maupay signed for £1.8 million and sold for $20 million just a few seasons later. This accumulated a huge profit for Brentford of £18.2 million. But how exactly do Brentford do it? How do they stay ahead of the fierce competition in signing players? Here is where I introduce to you the expected threat model they use. Now, what exactly is expected threat? Well, it's a performance metric used to analyse players' involvement and value added in the overall build-up to attacks. It's not dependent on whether the attack leads to a shot on goal, and the player involved doesn't have to directly contribute with that final pass or final shot. Let's go through an example of expected threat in a real-life match situation. Here I'm going to show you Marcondes' goal against Swansea City FC for Brentford in the playoff final, which led to them getting that promotion to the Premier League. At each phase of the attack, I'm going to pause and show you their expected threat value for each player in each position. For context, a low expected threat value, say 0.001, would mean a low chance of scoring in succeeding attacks. A high expected threat value, say 0.5, would mean you're very near the opposition's goal and have a high chance of scoring. Now let's see it for ourselves and press play. As you can see, Dalsgaard picks the ball up here and has a low expected threat of 0.02. He then passes it to Mbuemo, who picks it up here with an expected threat of 0.013, again quite low. However, he dribbles it half the length of the pitch, gaining expected threat the nearer he gets to the opposition's goal, and has an expected threat of 0.048 here, as he passes it off. He then gives to Roeslev, who has an expected threat of 0.089, again increasing as it gets closer to the goal, who then crosses it into Marcondes with an expected threat of 0.124, who does a fantastic finish and scores for Brentford FC. Come on, the Brentford. This is a diagram showing exactly what we've just seen, each player and their expected threat value at each position. Here you can see Mbuemo carried the ball so far up the pitch and contributed the most in the build-up to the attack. And you can see here Marcondes scored a great finish with the only expected threat of 0.124 in that position. Now, I'm sure you're wondering what exactly goes into the expected threat calculations, so I'll briefly touch onto it. Feel free to pause the video because I won't go into that much detail on it here. So firstly, the move probability goes on it. This is the probability of moving the ball through passing or dribbling in the next action. Shoot probability, the probability of shooting in the next action. Goal probability, the probability of scoring a goal in the next action. Transition matrix, the probability of moving from one zone to another zone. And lastly, the expected threat value, the reward value of having possession in that zone. So you can see expected threat value at the new zone is equal to the shoot times the goal probability, plus the move probability summed over all the zones. 16 by 12 is the grid of the 192 zones they use. The transition of moving the ball from the old to the new zone and times the expected threat value at the old zone. But don't worry, you don't need to know this in too much detail. And so to sum up, the expected threat model is Brentford FC's secret weapon into how they recruit players for a cheap price ahead of the competition and then can sell for much higher profits in the future. But let's keep that between us. Now we are going to investigate. Do clubs further down the division use the Moneyball theory to sign players? Is the technology available? Is the data available? Let's find out. Firstly, let's get into Forest Green Rovers FC. They currently sit top of the EFL League 2, and this is due to them implementing effectively the Moneyball theory, which is outstanding. Let's have a look at Forest Green Rovers FC's latest transfer business. As you can see, during the last 6 seasons, they've only had a net spend of minus 749,000 in total, which shows what a sustainable, well-run club they are and how they have implemented the Moneyball theory effectively to sign players for cheap and sell for profits. Forest Green Rovers FC's key transfer strategy is identifying players under the age of 24 with huge potential to have profits on in the future. They use 5 performance metrics per position, and this can be stuff such as expected goals, pass percentage, cross percentage, and many more. They then use Z-scores to rank each metric. Z-scores is just a measure of how far away a value is from the overall average. A key model they use in their performance metrics is expected goals. Expected goals measures the quality of an opportunity to score by calculating the likelihood that will be scored from a particular position during a particular phase of play. The scale is from 0 to 1, with 0 being no chance of scoring and 1 being a certain chance of scoring. For example, an expected goals of 0.2 would mean you're likely to score 2 in every 10 shots, 20% of the time. Now let's see a Forest Green Rovers FC's example. So their star striker Matt Stevens scored 2 goals in their 5-5 draw with Oldham Athletic. During this he only had a total XG of 0.95, as you can see from the diagram. So therefore he was just predicted to score just under 1 goal, so he overperformed with scoring 2. He had 1 shot that did not go in, and that was his hardest chance, as you can see, with an expected goals of 0.09. And his 2 other chances, he had a much higher chance of scoring, 0.65 and 0.21 respectively. A number of variables go into calculating expected goals. This can be such as distance from the goal, angle from the goal, pattern of play, and many more. And these all go into an algorithm which is used to calculate the expected goals. Each data analytical site has a different formula for calculating the expected goals, and they all keep them very secret. Therefore, it is impossible to know the exact formula. However, these are some of the variables they use within them. In this final section, we are going to see how we can improve Forest Green Rovers FC's transfer strategy by including the new expected threat model used so successfully at Brentford, to see if we can uncover the next gem, the next superstar for Forest Green Rovers to sign. Let's see how we get on. We're going to begin by adding expected threat into Forest Green Rovers' 5 performance metrics as the 6th metric, and we're going to add weightings to prioritise each metric. Adding expected threat will be effective as it will give players further down the pitch the credit they deserve in the build up to attacks, and it is perfect timing as expected threat has only just become available to League One and League Two sides. Having just spoken to first team performance analyst at the club, James Parsons has recommended me that they are looking to sign a middle centre-back who is dominant aerially and great at passing the ball out from the back to start attacks. Hence, I'm excited that we are going to perform our own analysis to see if we can uncover the next gem. Let's see how we get on. To begin our analysis, we have identified 6 performance metrics and have added weighting to prioritise certain metrics, with XT meaning expected threat. For instance, XT is worth double shots blocked per 90 and interceptions per 90, as we are specifically looking for someone with high levels of expected threat and are prioritising it over shots blocked and interceptions in this case. In my sample, I'm going to use all centre-backs in League 2 under the age of 24. I will then score them in each of the performance metrics. Then I'm going to apply Z-scores to rank the players in each metric. It essentially measures how far value is from the average. Positive means above average and negative means below average. And then I'll add weightings to double certain scores, for instance, expected threat. The next step was to total the Z-score for each player, and here I have found the top 5 centre-backs in League 2 that I'm looking to sign for Forest Green Rovers FC. So now we have identified the 5 best centre-backs in League 2 according to my metrics. I've gone on to add another variable of price, as the whole point about the Moneyball theory is finding the best value for money signing. Therefore, I compared each player's market value to their total weighted score to find the best value for money signing. As you can see from the graph, although Taylor was the best performing centre-back across the 6 metrics, he had the highest value of £1 million from a championship club and hence presented the worst value for money signing out of the 5. And M. Feeney of Carlisle United presented the best value for money, only costing £10,000 and scoring 5th out of all the performance metrics. Therefore, he is the one I'm going to recommend to Forest Green Rovers to sign. Overall, I'm really happy with my analysis and believe Feeney presents an excellent opportunity for the club to sign for cheap, whom they can sell on for huge profits in the future. I hope you enjoyed the video, and this is just one of many ways clubs can use the Moneyball theory and data to scout and recruit players. This is just the start of a really exciting era of technology in football, and I hope you enjoyed it as much as I did. Thank you for your time, and goodbye.